Welcome to this Oracle Mobile Cloud Service video, where we're going to discuss today the data offline and sync capabilities for the Storage API. G'day, I'm Chris Muir from the Oracle Mobile Platform team. In a previous episode, we considered how the client SDKs work with the server-side custom APIs in Oracle Mobile Cloud Service by defining sync policies and calling the endpoint API on the client side, and defining custom APIs with a defined set of REST APIs and structured payloads which you had to create. Alternatively to custom APIs, working with the data offline and sync features for the storage API is easier, as much of the work and configuration is already done for you, showing the difference between a declarative and custom built solution. For the storage API on the server side, you configure the storage API exactly like we showed you in the relating storage API episode playlist, simply by defining a collection, either isolated or shared. Unlike the custom API, where you needed to define a set of predefined REST endpoints and structured payloads, the server-side storage API takes care of all of this for you. Now, on a relating note, remember in the implementation code of the custom APIs, you can define server-side sync policies to override the client-side sync policies. Now, of course, for the storage API, as you're writing no code, you cannot do this. Rather, in the storage collections properties page, you can select the, get ready for it, the enable the mobile client SDK to cache collection data locally for offline use checkbox. This option, which by default is on, specifies to the client that it may cache the objects returned from the storage collection for offline use. Now, I'm sure you'd agree, with a single click, this seems like a really easy option. But what does it actually do under the covers? So here we've got our collection with the option turned on, and we'll quickly load up a test.json file as an object into the collection to demonstrate with. At runtime, when the client-side data offline and sync SDK storage code calls MCS to retrieve something from the server-side storage API, it will include a HTTP header in each request, Oracle Mobile Sync Agent equals true. With this option set to true, when MCS responds to the request, it will also look at the Enable the Mobile Client SDK option that we just configured in the storage API in the MCS portal. If the Oracle Mobile Sync Agent value is set to true, MCS will reply to the request with the HTTP header Oracle Mobile Sync expires and the date time. Now, as we discussed in previous episodes, this MCS HTTP header directs the client to only cache the data for 24 hours from the time of the response to the client. This default value is derived from the server-side environment policy sync collection time to live, which your admin can override. Alternatively, if we disable the Enable the Mobile Client SDK option on the storage API collection, on receiving a request from the mobile client with Oracle Mobile Sync Agent equals true, in responding, MCS will include the HTTP header Oracle Mobile Sync no store equals true. As the name implies, this directs the mobile client side data offline and sync functions to under no circumstances cache the data. In other words, the client will always have to request the data from the server. Only the most up-to-date data will do. So that little checkbox, which only takes one click to change, under the covers changes the interactions between MCS and the client-side SDK. And again, let's reflect on the fact that MCS is doing all the work for you here. There's not a lot that you have to do to handle all of this. If we put aside the server-side definition of storage APIs and the server-side sync policy options, what do you actually need to do on the client side with the storage API to work with all of this? On the client side, via the client SDK, you must use the client SDK storage API, not the endpoint API, which is reserved for custom APIs. Now, we have covered how to use the client-side storage API libraries in previous episodes, but let's have a quick peek at how to do it again. In this Objective-C example from iOS, you can see us retrieving a collections object. Note, unlike the endpoint client-side API for custom APIs, we don't go through the sync classes to do this. Also different from the custom API implementation is that for the storage API, the majority of sync policies are hard-coded for you. Namely, the fetch policy is set to fetch from service if offline. The eviction policy is evict on expiry at startup. The expire policy is expire after 86,400 seconds, which equates to 24 hours. The update policy is queue if offline. And finally, the conflict resolution policy is server wins. If you try to define these sync policies at the API level in your mobile platform's config file, such as omc.plist for iOS, they will be ignored. However, do note you can still define the global sync policies, such as periodic refresh and max store size. As you can see, for the storage API for data offline and sync, there is considerably less work to do, as unlike the custom APIs where you've decided to build your own API from the ground up, the declarative storage API takes care of most of the settings and work for you in terms of data offline and synchronization. Hope you've enjoyed this episode. Catch you in another episode very soon.